Okay. Yeah. Today we will start with the session on some of the hands-on. Actually, we had tried using the things. What is that? Things. Tinkercad. Sorry. Today we will have similar options with the help of another platform called as wokwi. In Tinkercad, we have simulated Arduino Uno. Okay. So, but for your project, some of you might require to use ESP32. Okay. For that purpose, maybe like you want to make use of the MQTT HTTP protocols. Okay. And you would like to try out. In that sense, you know, Tinkercad is not very much great at that. Okay. So we'll be using another alternate platform called as wokwi. Okay. There are still other platforms out there in the market. You can try out and explore yourself if you want to, but I will explore you on how to work with the basically on the wokwi. So let me share the screen. We'll go to the wokvi.com first. Okay, and you need to log into this one now first time, because I already logged in and I shown how to log in the previous earlier classes. Okay, how to log in is already shown to you people. If you don't have the account, directly you can create the account with your Google. Have you all created the login page? Now you need to select what? ESP32. Since we are going to use the ESP32 board. See, as told earlier, it can support Arduino Uno, Mega, Nano, three boards, ESP32 simulation, STM32, and Raspberry Pi Pico board. Okay, not the Raspberry Pi, 4 or 5 like that boards. Pico is actually microcontroller board. Okay, you can use any of these four microcontroller board. You can also install the wokwi to your VS Code. Okay, so also for the command line purpose, you can use it. JetBrains also it supports, but this comes under premium option. But still there is a free version available for the VS Code. If you get the license, if you go to pricing, and if you get free license, if you do it, if you want to install it to the as an extension to the VS Code, you can do it. Okay, yeah. So let's start with the ESP32 now. Okay, there are some sample codes are available. Okay, based on MicroPython and C programming. If you want, you can explore it. But I'm going to select a starter template with the help of ESP32. First, try a simple example of blinking an LED. Okay, by connecting it. Okay, so how does the things works here is actually this is the coding part, and this side is where you will make the connections, right? And this comes under diagram.json file. Okay, actually you can write a JSON code to make the connection. Okay, so if you are an expert experience, you can do that also. Okay. Mm, but here, if you can directly make the connection just like we did it in the Tinkercad also. Okay. So you need to add the components here. Okay, add a new part. This is for simulation. Click on run. Okay, for anything like extending this to full screen. Okay, so all that options are available. Okay, additionally, so I am going to include. I'll exit from the full screen. So I'll include LED, simple LED. It is there here. Basic components. Okay, display, 16 cross LCD. Like there are many peripherals are available. Can include them. So now I'll select a simple LED. Okay. You connect it to the any digital I/O pins. ESP32. Okay. So ESP32 has many digital I/O pins. It also supports I2C SPI protocols. So it has a built-in Wi-Fi. Okay. So that since it has a built-in Wi-Fi, you can push the data from the ESP32 directly to any of the MQTT brokers with the help of that. So you can also use the HTTP protocol. So I'll connect this one to this is a cathode and anode side. Okay, connect anode to pin number 13 and this one to ground. Okay, the code would be simple. Okay, I'll just rewrite here. Okay, so what code you will write? First, let us start with the simple code by setting up the in LED pen and LED pin is equal to 13. We are connected to the pin number 13. Okay, so then let us set the pin mode of the LED pin to output mode. That is the basic setup you have done. So now here digital write LED pin comma high delay of 1000. Then similarly digital write that's it. We can start the simulation now. So let me check. Okay, the simple LED blinking code. Complete it and let me know once you have finished. Once you complete it, you can save it. Okay, with something like or LED blink, something like that. You can save it. Okay. So the next example we are going to try would be an reading a DHT11 temperature sensor data and displaying it on the serial monitor. Then we'll use the LCD also for that. Okay. So what I'll do is here go to my projects. See here you need to click on the right hand side. Your account name will be there. Click here and select my projects and you can select a new project. It will show you all the projects what you created here. Okay. Now select new project. Again it is going to be ESp32. So it will ask whether you want to work with a MicroPython or Arduino. Select Arduino. Okay. So as I mentioned, next one would be on using a DHT22, right? So let's use a DHT22 sensor. DHT because DHT11 is not available. In DHT you have only one sensor. You can see that. So take this. So you know that DHT22 has total three pins. Fourth one is this is not useful pin, not connected. Okay. So this one is a ground, and here you have SDA, and here you have a VCC. Okay. So take this VCC and connect it to the VCC. Okay, 5 volt or 3.3 volt. SDA, that is the output of the your DHT22. It is the output of the DHT22. Connect that output to the pin number 13. Next, you have a ground. Bring the ground to the ground pin. So this is the connection which you need to do it. Okay, ground to ground This is your output pin, SDA pin. So that has to go to the pin number 13. Okay. So make this connection. So once you have done this connection, then you can go for the coding for this one. The steps you need to follow here is, okay, I have written here the steps which you should be following it. Make the connection pin 13 for DHT22 output. Okay. So similarly, what you need to do is install DHT22 library. You need to do that. You need to install the library. Okay. So then only you will be able to include that into your code. Okay. Because in the code, when we start writing the code, we will start writing like this. What is that? Hash include DHT dot h. Okay, when you write that hash include DHT dot h, okay, so it will not be included. You can see library manager is there. Click on the library manager and select plus here to include any library. Plus, let us select DHT. Here is the DHT 11 is there. DHT sensor library is there. Okay, so let us select the DHT. Okay, DHT sensor library. Okay, we have included that DHT sensor library. Then go back to the sketch.ino. Okay, so here we'll write our regular code. Serial dot begin. There is a baud rate. Okay, so we'll also include DHT dot begin. One second, guys. I'll just keep the charger. Okay, DHT dot begin. Okay, here hello. What we'll write temperature and humidity data. So here we'll write our main code. We'll start with by reading the temperature value with the help of a variable. Okay, so float temperature is equal to DHT dot read temperature to read the humidity again. Humidity is equal to DHT dot read humidity. So these two variables will provide us the these two functions, read humidity and read temperature, will provide us the humidity and temperature sensor data. Okay. So once we are able to read it, we'll display them on a serial monitor. Serial dot print temperature serial dot print actual temperature. Next, serial dot print humidity serial dot print. Okay, so you can give a delay of 1 second for next update. Yeah, so that's about the this of the temperature and humidity values. See, it will be a bit slower if you start uh, simulating more example in a single day, because it's a free version, and try to minimize per day simulations. Okay. Otherwise it will take more time to simulate a simple examples. I haven't written the I didn't assign the pin numbers. Okay, and the DHT type also I need to mention it. The same code will work for DHT11 and DHT22. Okay, so but we need to define that. Let's define first DHT pin. We need to declare that is pin number 13. I'm using it. So then let's define DHT type. It is DHT22. Okay, next DHT now. DHT. This is called as mapping between the DHT pin and the DHT type. So pass these two. The results started appearing here. It gives update for every 1 second. Okay, and here by clicking on this one, you can vary the temperature. Like you can simulate the variation, and that variations will be visible here immediately after 1 second. You can see that. Yeah. So we're able to successfully simulate the temperature sensor module on the ESp32 with the help of wokwi. So we had we have tried this DHT11. Now we'll do this on a I2C example. Okay, so we'll try to push this data, DHT22 data, onto the instead of putting it on the serial monitor. So we'll share this data into the LCD screen. Okay, so that we will try it. All right. So I will save this one. Okay. So DHT22 with oak ESP. I'll go to my projects and select a new project, and it's based on ESp32, and it is on Arduino. If any of you not tried it, you can do this one at least now. Okay, this is going to be simpler and easier. Okay, so as usual, uh, so let me write few things here. What you need to do, connection. So we need to pick up pick I2C LCD, and in that SDA pin goes to 21, SCL pin will go to 22. Okay, and then you will connect DHT to pin number 13. So these are the pin connection. Why 21, 22? These two pins support the I2C. Okay, you cannot connect that anywhere. Okay, DHT13 can be DHT22 can be connected to any pins. Okay, so all the pins will most of the pins will be acting as a digital IO pins, but not all the pins can act as a I2C pins. Okay, so now add a new part. So first we'll fix the DHT22. DHT22. This connection is easier. Ground to ground. SSPA to pin number 13. VCC to VCC. I will include the next part. LCD. Take I2C LCD 16 cross 2. You have to pick this 16 cross 2 LCD. Okay. So here the pin number 21. So that has to go to the ESDA, and pin number 22 has to come to the SCL. Okay. So then we have ground here. Let the ground go to ground, and we have VCC. Let's fix the VCC here. Okay. So this is the connection what you need to do it. So once you are done these things, okay, now go to the library manager. Okay, include libraries. DHT is already there, right? So include the liquid crystal LCD display. LCD liquid crystal I2C dot H. Okay, this one you need to include it, and include the DHT sensor library. Okay, now come back to your main code and continue. Say certain cases what happens is even if you don't include it, if you write it in the hash include, okay, automatically it will suggest you to include those library. Okay, you can just need to say click OK. That way also you can include the libraries. Sometimes if it is not able to give the suggestions, so you need to do the way I showed manually. Okay, hash include. So there is a wire.h, include it. Hash include liquid crystal I2C.h, hash include the ht dot. Okay, the same code we need to write it whatever we wrote it for the previously, right? So that is you need to define DHT pin to 13, hash define DHT type, that is DHT22, then DHT library, DHT pin, comma, DHT type, map those two. So this is over. Similarly, liquid crystal display, liquid crystal I2C. Need to mention the pin numbers what we have used. Okay, 0x27 is the address. If you remember this, we have done it during our one of the class. Okay, it's a type is 16 cross 2. Okay, so that's the basics of it. Now we'll go ahead with the course. Let's begin with the dht.begin. Yeah, initialize the LCD. So LCD type is backlit. Let's set the cursor of the LCD. Where? To the starting position 0, 0. First row, first column. So let's print something onto that. Print what I'll print? I'll print the temperature into this one. Okay. So I'll say weather monitor. That's it. Over. That's what in the beginning delay of 2000 and LCD dot create. So this is what in the beginning happens. Okay. So next part is where we will try to read the temperature and the humidity both. Temperature is equal to dht dot read temperature. That's the function float humidity is equal to dht dot read humidity. First set the cursors to first row, first column. Here LCD dot print temperature is equal to, I will just write LCD dot print temp comma comma 1. Then similarly LCD dot set cursor to the first row, first column. LCD dot print humid. I'll just keep 3 letters because you can only display 16 characters. Okay. LCD dot print humidity 1. So if you want to mention the percentage, you can mention it as a percentage. Otherwise, you can ignore it. Okay. All right. You can give some delay of 1 second so that it will update for every 1 second. That's it. You can simulate it now. We'll just verify it. So this is one mistake. Now I'm trying to simulate it. Mhm. Mhm. All right, guys, the simulation is taking more time. Okay, it would take some time to compile, but all the codes, everything connection is fine. Okay, you should be able to get the results. And what I'll do is I'll be sharing and uploading these videos, and also I have the PDF file. I'll share with you people so that you can try at your home. Okay, but try to complete this today itself. Okay, or tomorrow if you're trying, do it in the morning itself so that you have sufficient trials for the evening. Otherwise, create one more additional account for the tomorrow afternoon purpose, evening purpose. Okay. So tomorrow we're going to complete the final session that is on things code. Because I could have taken it now itself because I'll not be able to simulate it because of the restriction. Okay. All right. Thank you. And if you have any